All right, so it's being streamed right now. Um, just so that everybody know where the channel is, it is on YouTube, and I'll just write it down one more time because just in case someone missed it last time, this is on YouTube as a channel, some profs, and the videos are named according to the day of the recording and also the class. So with this one, like today, right now, it's going to be 2018-1022, which is the date, and then cisp300, which is the class. Sometimes they don't get renamed, so it might just read a whole bunch of question marks, but you can tell from the time of the recording that it is for this class. It's also from the length too, because this is the only class that I teach that is 2 hours long. So if you see something that's close to 2 hours long, it's this class. Okay? So are there any questions about the material from last Friday? No questions? All right, so if there are no questions, what I'll do first is to go back to the ungraded assignment that I sent to all of you. If you're enrolled in class, you should receive an email with that announcement. If you're not enrolled in class, well, actually, I put a few people on wait list in the class, so those people should receive that notification as well. And this is the ungraded assignment so that you can get some hands-on exercise to trace the code. So in this case, we have this little table here with only 3 rows for you to fill in, which is appropriate because there are only 3 lines of code for you to trace. So we'll go ahead and figure out what those values should be. The best way to do this is to do it on a spreadsheet. So what I'll do is I'm going to start up a spreadsheet and do it on the spreadsheet. I'll name the spreadsheet after today's date, so that way I can put additional tabs to that spreadsheet of everything that I do for this class today. So this is cisp300. So I hope most of you, if not all of you, have time to go over the material and at least go over the material up to where I left off last Friday. Yes, go ahead.
I was actually going to ask about that. What's the path to go to the material for each class? You said we could follow along on our laptops.
So the class material for this class, let me just kind of close the door. So everything is on Canvas, okay? There's some material that I have not released on Canvas yet, but you cannot really find it anywhere else anyway. So all the topics are in modules. So the home page for this class on Canvas will list a whole bunch of what I call modules. And these modules are basically the reading material for this class. So last week, we went through the entire section of Is Computer Science for You? And then we got started with introduction, which talks about pseudocode and algorithm. We also basically finished the entire module of variable, assignment statements, and sequences. So that's basically where you find the reading material.
Okay, I think I was confused. I thought we had finished all that, but I see we're at conditions and conditional statements.
Right, so we just started last week on conditions and conditional statements, and today we'll finish that, and hopefully we'll get to loops as well today. So once we cover those two, then we'll do some exercise of tracing algorithms, and then we'll start on the next one, on Wednesday. So we'll see how far we can go today. But before we go any further, what we'll do is we'll trace this pseudocode in a spreadsheet, which is going to be basically how you do all of the homework in this class. So I go to the share folder. If you do not know how to use Google Spreadsheet, now is a good time to get familiarized with Google Spreadsheet. How many people have used a spreadsheet before? Excel, LibreOffice, that sort of thing? Okay. If you're shaking your head, now you have to learn how to use one. Okay. So go to Google Drive, which you already have. You just have to go to apps.lostreels.edu. Every enrolled student has an account over there. So you go to New, and then you click on Google Sheets, and that will automatically create a Google spreadsheet for you. In this case, because I'm creating it in a share folder, I got a warning just to make sure that, yes, I intend to share this document. So once you get into a spreadsheet, the first thing I would do is to rename the spreadsheet so it reflects what you're doing with the spreadsheet. Yep, my computer is a little bit slow. Today is 2018, October 22nd. So I'm just going to use the date of today to name the spreadsheet, so this way you guys know, oh, I need to go back to the spreadsheet on a particular day, and this way you can locate that spreadsheet pretty quickly. All right, so I'm going to go start with tracing this algorithm. It really helps if you can look at the code and look at the spreadsheet at the same time. Okay, so there are several ways to do that. One way to do it is to go to the spreadsheet and then right-click and open it as a new window. So click on, it doesn't have that option. It doesn't have the option to turn it into its own window. You can drag it out, yeah, but it's not exactly what I was expecting to have to do. Because I remember, at least with another browser, you can just right-click on the tab and it gives you that option. And it doesn't. I can try to move it to expose the algorithm. There we go. Okay. So now we can get started with the trace. With every single trace, you start with the naming of the header of each column. And one column is always going to be a line number, because I need to know the result, I need to know the line number corresponding to the effect on the variables. So one column has to be line number. And then you need one column for each variable in the program. So in this case, we have 3 variables. X, Y, and Z are the variables. And then the first line or the first row is always a precondition. The precondition is basically telling you what can we assume about the values in the variables before the algorithm starts. Sometimes they start with actual values, like in this case, and other times they may not start with any actual values. If they do not start with any actual values, you can use a question mark. Okay? So as a quick reminder, there's no drink or food policy in the classroom. So I don't drink my coffee either. So we'll take a break at about 7 o'clock and we can have our food or drink at that time. All right, so I'm just going to copy the 4, which is the precondition of variable x, the 10, which is the precondition of variable y, and also the 2, which is the precondition of variable z, into here. And then the rest is just based on the actual pseudocode and how I trace it. So are there any questions at this point about the tracing of this algorithm? Now you can also see how the columns are getting a little bit too wide. They're much wider than they need to be. So you can click on the column itself and then shift click on the last column, and then you hover the mouse until it turns into this little icon. Then you can drag it to resize the columns all at the same time, which I find to be a quite useful feature. And of course in class, sometimes I need to zoom in a little bit because this projector is not particularly big, so it helps to zoom in a little bit. All right, so now we can move on to first line. The first line says x gets x plus z. So what do we need to do? You have an assignment statement because we have a left arrow symbol, which means we have to evaluate the right-hand side. Whatever the value of the right-hand side is, we use it to update the variable on the left-hand side. So it's always a 2-stage kind of process. First stage, evaluate the right-hand side. Second stage, update the left-hand side. So we start with evaluating the right-hand side, which is x plus z. X currently has a value of 4. Z currently has a value of 2. 4 plus 2 is 6. So now we need to decide what do we do with the value of 6. We look at the left-hand side of the assignment statement, which is z, which is what x. So we update the value of x to 6. The rest are the same. So for now, I'm just going to copy these two. Okay. Sooner or later, we'll just leave them blank because otherwise there won't be enough time to make copies. So what we have here is the effect of executing line 1 of the algorithm. Variable y is not changed. Variable z is not changed, but variable x is changed from 4 to 6. Is that okay? And the 1 in column A indicates that this is the effect of executing line 1. Yes?
So it's not sufficient to just fill in the ones that change. We have to fill in all the columns all the way down.
Well, you don't have to. I mean, later on, I would give you guys a shortcut so that if something is not changed, you can leave it blank. So if you prefer to do it this way now, we can start to use that convention.
Whatever you want us to use for the rest of the class.
Well, I mean, for now, we can use either one. So a blank means, it has not changed. Is that okay? Mm-hmm. All right, cool. So now we move on to line 2 of the pseudocode. So with line 2, we look at the assignment statement. We identify this as an assignment statement because of the left arrow symbol. Whenever we have an assignment statement, what do? Evaluate the right-hand side, update the left-hand side. So in this case, the right-hand side is y plus 1. So we find out what the value of y is. So when you look up column C, you have to look up the last update value, the last value of y, which currently is 10. 10 plus 1 is 11. And then we update y with 11 because y is also the variable on the left-hand side. So that's why we go to this particular cell, change it to 11, and then we are done with line 2. Because line 2 does not change x, it does not change z either. So we are done with line 2. Are there any questions about line 2? The execution thereof. Okay. Let's move on to line 3. So line 3 is a little bit longer. Let me move this over a little bit. So line 3 is z minus x plus y in parentheses. So we have to figure out the current values of x, y, and z to figure out the right-hand side. X currently has a value of 6. Very good. Okay, so the 4 is gone now. Okay, there's no way we can actually know, at this time that x had a value of 4. It has a value of 6. And then y has a value of 11. 6 plus 11 is 17. And then we are subtracting 17 from z. Z currently has a value of 2. 2 minus 17 is negative 15. So the right-hand side evaluates to negative 15. What are we doing with that value? Update the left-hand side. What is on the left-hand side? Z. So the new value of z is now negative 15. And that concludes the trace of these 3 lines of code. Question? Go ahead.
Yeah, so the x value didn't update when you changed to 6 instead of 4. So
On which row?
on row 3.
On row 3, yes.
So on row 3, it shouldn't be 2 minus 6 plus.
Now, the nice thing about a trace like this, oh, okay. Yeah, the nice thing about a trace like this is, you can always go back and figure out, why a value changed on a particular line, because, each row gives you all the information that you need in order to recreate that scenario. Is that okay? So are we doing okay? All right. So as a convention, I always also put a post here, which stands for post condition, which basically means we're done. Okay, it's the same thing as a QED in a math proof. Okay, or just the word end, to mark the end of something. So are we okay so far with this example? It is your ungraded assignment over the weekend. Does that mean that you have to do it? No. Does it mean it's a good idea to do it? Yes. Does it guarantee that if you do it, you get a good grade out of this class? No. Maybe. It improves your chances. Okay, yep. That's all I can say. It improves your chances. All right, so do we have any additional questions about assignments, variables, self-referencing assignment statements, and the way we do traces for these sequences of operations? Yes?
Question about homework.
Uh-huh.
Using the Google Sheets to do our lines of code.
Mm-hmm.
You want us to export that as like a PDF or a Sheets
Nope,
document?
I just need a link to it. That's the beauty of it. So this way you don't need to save it to a particular file. You don't have to put it on a thumb drive. There's no way to lose it because the moment you get it done, you just give me the link to the document and we're good. Mm-hmm. All right. So now that we're done with the announcement, which is the ungraded assignment, let's move on to conditional statements. And last time, we kind of talked about the less than comparison as well as the logical operators. So we're going to go back in time a little bit and talk about those particular things. So everything that we will be focusing on today is on this particular module as well as the next. So I'm going to open this one in a new tab. And last time we talked about comparisons and also logical operators. So section 3 was basically covered entirely on last Friday. I also kind of threw in something extra. We talked about the NAND operator and how everything can be done with just less than and the NAND NAND operator. Now the NAND operator I just threw in for fun. Okay, so that's not going to be what we use in this class. So now we'll actually start to talk about what a conditional statement is. So basically, if you look at a conditional statement, it's a way to make a decision. In other words, sometimes we want to perform a particular operation. Other times we want to perform a different operation, depending on what we call a condition. A condition is nothing more than a question that has one of two possible answers, true or false. Okay? If it's true, we go in one direction. If it is false, we go in a different direction. That's how we make decisions when it comes to programming. So instead of reading my notes, okay, which is I'm going to use exactly the same example, I am going to do it as a live sample. Okay. The podium is not the best way to do this, but it's gonna be okay. I want to do it this way because I can show you interactively, how an algorithm is derived. Because part of the purpose of this class is to help you understand how algorithms are designed. So this is what we'll do to this end. All right. And this is cisp300. Last page. And I'm going to have to fold this up. There we go. You can show the screen. There we go. Okay. So we're going to tackle the same problem that we started off last time. How do we find the maximum of two variables and make the third variable the maximum of those two? Okay? Oh, that's fine. It's just complaining about. Okay, it's working. All right. So to find, okay, so we want to go through a few examples first. Okay, so just so that we make sure that we understand what it is. So if z is the maximum of xy, what does it mean? Okay. So now we need to say, okay, what is the maximum of 4 and 6? What do you think that is? 6. Okay. What about the maximum of 4 and 4? 4 itself. Okay, very good. One last example. What is the maximum of 4 and 2? 4. Okay, so we understand the concept of maximum. Later on in this class, we'll try to use conditions to specify the definition of maximum. You might think it's pretty simple, but it's actually not as simple as most people think it is. But we'll get to that later. For now, what we'll do is we'll say, I want to write, okay, so given x and y, find the maximum and store it in z. So this is your given problem. How do we do it? Well, it's not simple as in, we can do it in a sequence because we don't know which one is actually the maximum. Sometimes x is the maximum, sometimes y is the maximum. So I cannot really just say z gets x or z gets y because sometimes I want this and sometimes I want the other one. Okay. So in terms of a picture, what it looks like is this. Sometimes we want z to get the value of x. Other times we want z to get the value of y. So if you think about this as a trail map, okay, like you're on a hiking trail and you're looking at a map and you want to kind of choose your own path to walk around a park. So we look at these two as activities that you can do along the trail, and they are coming off of a branch. But these two activities will also merge again when you're done, so that they exit at the same exit point out of that portion of the trail. So you come in, and then you are at a junction. At the junction, you have to make a decision. Should I make a right-hand turn, or should I make a left-hand turn? Is that okay? So if you think about it this way, then you think about, okay, what question do I need to answer to determine which way I should go? Well, if I go in the direction, if I make a right turn so that z gets x, I think I only want to go there when x is at least as large as y. Is that making any sense? If x is at least as large as y, then x is the maximum of the two, and now I can have z to update to the value of x. Seems to make sense. What about the other one? Well, whenever x is not at least as large as y, I would go the other way, because y is going to be the maximum in that case. Is that making any sense? Okay. So the question here, so now I need to label the paths. Okay, this is also very important. My convention, which is really just my convention, is I label the left path true, and I label the right path false. Okay, just a convention, but I stay very consistent with this convention. So now the question is, what should I ask here? So imagine that you have a little post with a little question along the trail. What question should I post here so that by the time I exit this part of the trail, z is the maximum of x and y? That's the question. Yep.
If x is greater than or equal to blank else.
Yep. Yep. So the question here is, if x is greater than or equal to y, if it is true, then we go to the branch where z is updated to x. Otherwise, we go to the other branch, which is z getting updated to the value of y. That seems to get the job done. Is that okay? So are there any? Yeah, go ahead.
You can ask if y less than x.
You can. That will work as well, because when they equal, then you can use either one to update to z. You can do that as well. So x is greater than or equal to y would work. X is greater than y would work as well in this particular case, yes. But I'm going to stick with this one just for now. Okay, so do we have any questions about this trail map, what it is supposed to represent? So what you kind of need to imagine is when you walk into this path here, you have two little post-its. One little post-it has the value of x, the other one has the value of y, and then you have a blank post-it that is z. So you walk in, you look at the fork, and you ask, I can only go to one of these two branches. Which one should I go? Well, guess what? There's a little post with a question on it to help you decide which way you need to go. The question is, x is greater than or equal to y. Is it true or is it false? If it is true, then you follow the path to your right-hand side, and then and then you update the post-it with z on it, so that it has the same value of the post-it with x on it. Otherwise, you follow the other path and update z with a value of y. But the key is you can only follow one path at a time. You cannot go on both paths at the same time so that z gets updated on both sides. You can only follow one path at a time. So are we okay so far with this picture? Yes? Okay, excellent. So now we're going to do some abstraction. Okay, programming is all about abstraction. Can someone describe what does it mean when I say abstraction? What does abstraction mean? What does abstracting mean? Come on. You guys can use a phone. You can Google. I think most of you know what that word means. Okay, kind of. Okay, it's losing details. That's basically what it is. Abstraction is moving on to, quote unquote, a higher level concept by losing details. Okay, so just so that we know how it is defined on the internet, we'll ask Google. So we say define abstraction. And it comes back with an answer of the quality of dealing with ideas rather than events, freedom from representation qualities in art. Okay, so that's not exactly what I want. Okay, let's look for abstract. Existing in thought as an idea but not having a physical or concrete existence. Consider something theoretically or separating from something else. Extract or remove. Okay, none of it says the removal of details, but let me tell you, it is the removal of details.
Abstraction in computer science, process of removing physics, spatial, or temporal details or attributes.
Thank you. Good job. Cool. So it is the losing of details, which I'm very good at, unintentionally. Some people are very good at maintaining and keeping track of details. I am very bad at it. Okay, which means I'm very good at losing details, which turns out to be important in certain things like computer science. So what do I mean by abstraction? Okay, so let's go back to this picture. This is the conditional statement, or a particular way of using conditional statement to solve a particular problem, which is finding the maximum of two variables. Okay, so but that turns out to be a pretty useful construct in computer programming in general. So what do? We abstract it. So what do I mean by abstracting it? So what I'll do is I'm going to lose some details. Yep.
Are you going to turn it into an if-else
Yep.
statement?
Yep. So what we'll do is we'll lose some details here. What details are we talking about? So here comes the dreaded eraser. Okay. Now don't worry, because everything is being streamed, right? So whatever I have done before is already on YouTube. If a nuclear warhead is to hit Sacramento right now, that will still be around. Not that you would care in that case anyway. Okay, so now we lose some details here. Okay, this is just a condition. It's really just a question that has true or false as an answer. So we just abstract it to a question mark. Okay, give me a question that can be answered with either true or false. What I do here is just some kind of operation. What I'm going to do here is some kind of operation. We can lose track of the detail. So what is left here is a template. It is the template of a general purpose conditional statement. So what are the three main ingredients of a conditional statement? What are the three things that I just erased? A question, something to do when the answer to the question is true, and something to do when the answer to the question is false. Is that okay? That is the essence of a conditional statement. So are we okay so far with this example? Okay. So now we go back to the notes. Okay. Let me see where we are at this point. So now we look at listing 1, okay, which is not consistent with what we just said, but it does give you the construct of the 3 things that we have just talked about. The first one is the question. This is the question. Something to do when the answer is true. This is the something to do when the answer is true. And something to do when the answer is false. That is the something to do when the answer is false. Okay, wait, hold on a second here. This is all using words and characters and stuff like that, symbols. And then the other one is a picture. So how do these 2 things relate? Yeah, go ahead.
The branching occurs after the if statement.
Well, those 2 relate just as different representations of the same concept. Okay, so that means, if I want to do exactly what the code is specifying, I just go back and repopulate these. Now let me turn this one, move it to the side. Oh, perfect. I can actually fit everything on the same screen. So now we have 2 representations of the same thing. Okay, one is using words to describe it. The other one is a picture to describe exactly the same thing. They're both conditional statements. Are we doing okay so far with the concept of a conditional statement? I only used the pictures for the first 2 weeks or so, maybe just 1 week, because this is a compressed timeline. Why do you think we are not going to use pictures much more after the first week? Takes too long. Yep.
Because we code and we use words to code.
We use words to code. Okay. Yep.
Too many options.
Too many ways to draw pictures, right? Too many degrees of freedom, so to speak. Yep. The pictures will get too big, and if you want to edit, if you want to change your code, good luck. Okay. So there are many reasons why we do not use pictorial programming. Now, there is such a thing. For those of you who want to experiment with pictorial programming, look into MIT Scratch. Okay, MIT Scratch, just look up MIT as in Massachusetts Institution of Technology, and then Scratch as in what cats do, okay? And you will find a programming interface where you can just drag and drop blocks of control structure, and you can make your conditional statement kind of graphically. But it's really severely limiting because you can't really construct programs in a really fast way, as in typing. So that's why at some point we're not going to use the picture anymore, and we'll only use the text representation. So what we need to do now, what you guys need to do now, is to, in your mind, establish the equivalence. When you see something like this, you need to have the same understanding as something like that. Is that okay? More or less? Okay? So they're really just 2 different representations of the same thing, but pseudocode is the way that we are going to use from here on. The graphical way is only here to help you understand the concept. Once we understand the concept, we get rid of the pictures. All right? Has anyone heard of the term flowcharting? Okay? And many people use flowcharting for a class like of this level. I do not, for a very specific reason. It leads to spaghetti code. Does anyone know what is spaghetti code? Yep, go ahead. You want to explain what spaghetti code means? Give it a try.
Disorganized code that is kind of like, so for example, I want to read someone else's code and I'm trying to read it.
Mm-hmm.
It's hard for me to read it, so that's why it's called.
It's difficult to follow.
Yeah, follow.
So if something is broken, it becomes almost impossible to track down the source of the problem. Yep, that's it. So spaghetti code does not necessarily mean it is incorrect or it's faulty or has bugs. It simply means it is very difficult to maintain. And code that is difficult to maintain is definitely not desirable? Why is it not desirable? Hmm? You cannot easily build on it. It's not, yep, go ahead.
You're not going to have the same employees for the entirety of the program's lifespan for the most part, so you want to have people that can come in at any point and catch up to what's going on in a relatively short time.
Exactly. It cannot be picked up by other people easily, which unfortunately leads to the belief that I should write more spaghetti code for the sake of job security. Does anyone read Dilbert? Yeah, long time ago. Do you guys know who's Wally? Yeah, that sounds like something that Wally would do. He would read a book on how to write spaghetti code, not to avoid spaghetti code, because he wants job security. Just to share with you, there's one particular comic strip when the boss, the pointy hair guy, said, for every bug you fix, I'll give you X amount of money. And Dilbert was walking by Wally's office and asked, Wally, what are you doing? Wally said, I'm writing myself a minivan. So what do you think he was doing? He's intentionally putting bugs in his code so that he can fix those later and get paid. All right. But the pointy hair guy, which is the boss, is not well known for being smart. There was another strip where he had a tablet or a laptop computer, and he was asking Dilbert how to turn it off. And I think, I don't remember whether it was Dogbert or Dilbert who said, just shake it like this, upside down. And he did it. The pointy hair boss just did that. Okay, so getting back here. So now we understand what is a conditional statement in a very specific case. So when we abstract it, okay, we've seen that picture before, just drawn a little bit differently. So it's still a pictorial representation. And going like this, it's starting to look like a biology class, right? Except we don't have an organ like that. We also talked about logical operators, okay? So now the question is, we know how to find the maximum of 2 variables. How do we find the maximum of 3 variables now? That's the question. What do you think? Let's start with a picture. So I'm going to switch back to the tablet. And this time we have another picture. So I'm going to move this one back to the main portion of the screen. All right, so the job is, the thing is, we have 3 variables. We have, I'm trying to remember the symbols that I used here. So let me see, W, X, Y, Z. Okay, so we have variables W, X, and Y having some existing values. We want to find the maximum of W, X, and Y and store that maximum to Z. So is it clear what I want to do? Okay. So I'll just comment here. Okay, so I'll just write down the comment of what we are about to do. So we want Z to be the maximum of not 2, but 3 variables, W, X, Y. But now we need to figure out the code to do it. So you can kind of use the same approach as last time and say, well, sometimes W is the maximum, and we just want to update Z with W. Sometimes X is the maximum, and we want to update Z with X. And then some other time, Y is the maximum, and we want to update Z with Y. So now the question is, how do you structure your code so that you're only going to use a conditional statement? In other words, we're going to use things that looks like this in a particular way to express the logic that we need for something that seems to have 3 branches instead of 2. So now the question is, well, Tag, you only gave me something that has 2 branches, but now we got 3 branches. How are we going to do that? Well, go ahead.
Sorry, a default statement?
A default statement. There's no such thing as default statement.
As in, like,
Then you have to do it first, and then you do the optional stuff later. But that's not what I want to show. I understand what you're saying, but that's not what we're going to do. We want to use conditional statements, which only inherently has 2 branches, but we want to somehow have 3 branches. Yes, go ahead.
You use a sequence of conditional statements feeding off one another?
Yes. So we are connecting pieces now, right? So what we're going to do is we put a conditional statement into another conditional statement. Go ahead.
Can we use and?
We can use the word and, but that only changes what you can put on the post, as a question that still only has one of 2 possible answers, true or false. So you're still limited. Every time you make a decision, you're still limited to only 2 choices. Okay? So now the question is, how do we end up with 3 branches when you can only branch to 2 each time? Yep. Using the else if statement, that is correct. But how does it look like in a picture? Because remember, we are just starting to get into this. So we need to kind of map it into a concept first. So I'm going to scroll off. Well, maybe scroll back a little bit here because I got a little bit of room here to show that concept. So what we have here is a branch. Okay, this is the basic conditional statement. Okay, like so. Okay, like so. They merge. Okay, we have 1 entry point, we have 1 exit point. We got a question here. We have a true branch, we have a false branch. Okay, that's the template of a conditional statement. Not yet, not yet. Okay, but they only got 2 branches. But we need 3 things. Okay, we need to decide one of 3 things to do. What about this idea? You look into this thing here and you say, let's do another conditional statement in here. How about that? It's called a nested statement. In other words, the small conditional statement is said to be nested in the else branch of the larger conditional statement. Okay, this is the concept of nesting. Do we use the concept of nesting in real world, when we are not programming? How do we use that concept in real world? The concept of nesting or having a container that can be inside another container? When do you use it? Have you guys opened a file today?
Yes.
Where is that file? It's in the folder, right? Where's that folder? In another folder. Okay, very good. So the folder structure on the computer file system is nested. Okay, so the root folder is C:\\, right? If you're using Windows. If you're using a Mac, it is probably /user/ whatever your username is. Okay, do you put everything in C:\\? What would happen if you did? It will take a long time to find something. Why?
They would have to sort through everything as opposed to selecting certain directories.
Exactly. How many files do you think you have on a typical PC? Doesn't have to be super duper powerful, just a normal Windows 10 machine that is run of the mill. Okay, give me an order of magnitude. Do you think we have hundreds of files, thousands of files, tens of thousands of files, hundreds of thousands of files, or what? I would say it's between tens to 100 of thousands of files. Okay, so imagine all of those files in the same folder. How are you going to find that picture that you took with grandma last Sunday? You can tag. You have some ways to do it. Okay, but it's not going to be easy. What about the homework assignment that you did with English Writing 300 that you did like 2 weeks ago? It's going to be challenging, okay? Because as you add more and more and more files, you got a few challenges. One is you have to find what files are already there. 2, is you have to find new names for new files because you cannot use the same name for two different files in the same folder. Does that make any sense? Now, on the other hand, if you have homework 1 for your English class, homework 1 for this class, homework 1 for your US history class, and homework 1 for your psych class, well, guess what? That's fine. If each class has its own folder, you can reuse homework 1 as a file name. It's not a problem. So that is why we have nested folders. How does it get back to what we are talking about here?
We're evaluating multiple variables within one branch.
Yep. So one branch only has to do with one particular case. The rest, we leave it to the other branch. And then we can have additional conditional statements in the other branch to help differentiate, okay, which one of these two is the maximum now. Is that making any sense? So that means in this case, the first question, uh-oh, I just clicked on something. I think I clicked on the camera app. And it's looking at nothing because the rear camera is actually looking on the table. There we go. Yeah, I think I just clicked that camera button. All right, so now, so what do we ask here? In other words, what condition is true will make sure that W is in fact the maximum. So do you see how I'm going backwards to reconstruct the code? By looking at what kind of control structure I need, what kind of condition I need, and then go back to repopulate this picture. So what condition will confirm that W is, in fact, the maximum? We can use conjunction, which is and. Yep. Okay, sure. So we'll say, W is greater than, greater than or equal to X and W is greater than Y. Okay, so that little inverted V symbol means and or conjunction. Okay, that was introduced in the previous class. Or not? Yes?
It was.
Yeah, I think so. Yeah. All right. So what does it mean if I go to the false branch? In other words, if I end up here, what does it mean according to that sign on the post?
That either condition is wrong, not necessarily both.
At least one of those conditions is not true. In other words, we know that X is greater than or equal to W, or Y is greater than or equal to W. But both, one of those two at least, will make W not the only maximum anymore. It can still be a maximum, but not the only maximum anymore. Is that making it? Yep. Mm-hmm.
So if we find out that X or Y on the false branch is less than or greater than W, how do we find out which would be assigned to Z?
Well, very good. That's a good question. So I'm going to label the branches now. Okay, so this true. So remember what this true is corresponding to. This true is corresponding to the confirmation that W is greater than X and W is greater than Y. That's what the T is indicating. So now if I want to label or comment on this branch here, what does it mean? If I follow this branch, what condition has to be true? Well, the lazy way to do it, okay, let me show you what is the lazy way to label this one, is it is not the case that W is greater than X and W is greater than Y. Does that make sense? Because if that were true, I would have gone for the other branch already. But this is not a very easy way to read it, because all it does is to say, oh, the negation of whatever the condition is. So let me propose a different way to write this. I'm proposing that this can also be known as it is not the case that W, oops, I take it back. Yeah, it is not the case that W is greater than X, or it is not the case that W is greater than Y. Does that make sense? The V means or. Seems to make sense, right? Now, if that is true, can I further rewrite this as W is less than or equal to X, or W is less than or equal to W, less than or equal to W, less than or equal to Y. All right. So if you look at this and go like, if at least one of these two is true, W is definitely not the only maximum. There is a chance that X is the maximum. There's also a chance that Y is the maximum. Is that okay? Okay. So that means coming into this inner conditional statement, you have a smaller problem to solve because you know certain things already. You already know that W is less than or equal to X, or W is less than or equal to Y. You already know that. You just have to know which one. Yep.
Do we have to do another nested statement to compare X and Y?
Yep. So that's basically what you need to do. So now you look into this little post line here, smaller one. But we can zoom in, right? So we can say we zoom in, we look at this one, and all it needs to do is to now say, I just need to know whether X is less than Y. Okay, or if we want to preserve the order of WXY, we can say whether X is greater than Y. Because we know W is not going to be the answer at this point, okay? So we just need to know, okay, we know one of these two is going to be, at least one of these two is greater than W. Which one? So we compare these two. If X is greater than Y, and we also know that W is less than or equal to X, or W is less than or equal to Y, that makes X the maximum. So that means if I look at this little thing here, it should say, Z gets the value of X. This will say Z gets the value of Y. Does that make sense? So this is how we use a conditional statement which inherently only has two branches. But because of the way we do nesting, we now end up with three branches because we are nesting a conditional statement into one of the branches of another conditional branch. Is that okay? So if this is what the picture looks like, how do we write this in pseudocode? That becomes the next question. Okay?
We back up to X is greater than Y on the other side there on the fault side in the nested statement. So when X becomes greater than Y, W is what in relation to Y?
Well, we already know that W is less than or equal to X, or W is less than or equal to Y by the time we get to the inner conditional statement, which means we know that the maximum is going to be X or Y. W is not the unique maximum. W can still be a maximum, but it's not going to be unique anymore. Is that making any sense? So that means I only have to compare X and Y at this time. Whatever is larger between the X and the Y becomes the maximum. Is that okay?
Right, because if we take that side, then we have those two conditional statements to deal with, and whatever the result is the path that it takes.
You mean relative to this side?
Yeah.
Yep. The fact that we are not taking this side automatically means that X or Y is the maximum.
Right. So so if we don't take the quote true side, I guess at this point true and false is sort of misleading.
Well, this is true too, and this is also false.
Right. But
Okay.
if we don't take the W true side, then we take the false X and Y side, and then we find the true false from those two.
Correct.
And then it takes its own path.
So now we have a problem with naming the path, because which one is, when I say the true path, when I say the false path, which one are we talking about? Well, how can we resolve this situation? How do you follow the paths of folders in your file system? Okay, same way. This is the true path from the root, right? This is going to be the false true path. This is going to be the false path. The same way you would name, the folder path, in a file system. Is that making any sense? No? Yes? Kinda? A little bit? Okay, but how do we write this code in pseudocode? Now that we know what it looks like in the picture, what does it look like in pseudocode? How do we construct that? Well, we know that it is a conditional statement on the outside, and then one of the branches has its own conditional statement in it. So the way I do this, okay, and I can do this using a text editor. I can just reuse this one. This is from from my earlier class. Sorry? Okay. So we know what a conditional statement looks like, right? That's what it looks like. This is the outer one. The inner one, where is the inner one? Is the inner one between the then and the else, or is it between the else and the end if? Between the else and the end if. Why? Because it is, exactly, it is when the answer to the question is false to the first question. Okay, very good. So we know it's between these two. So now we do exactly the same thing. If blah blah, then else, and if. It's a folder inside a folder, same concept. What about, so now we go back and fill in the details. So the outer one, if I remember, well, I can look at my tablet at the same time. You cannot see the tablet right now. So we can say this is x is, w. W is greater than x, and w is greater than y. Then we performed this branch here. And then the inside one is comparing x and y only. So this is saying if x is greater than y. Okay, so I'm going to put the tablet right next to this, just so that you guys can see both the text version and also the graphical version. Is that working? Do you see how the condition of the outer conditional statement is here, and then the condition of the inner conditional statement, which is here, is actually inside here? Yep.
Clarification on 5 and 6 line of code. The if is just saying that it ends the if algorithm.
Yeah, it really is just a marker to say that this is the end of the conditional statement of the same indentation level. Okay? So now we have to backfill a few more things, which is what do we do inside each branch? So inside this branch, z gets the value of w. And then inside this branch here, z gets the value of x. Inside this branch, z gets the value of y. Now we have the entire algorithm coded in pseudocode. All right. It's 7:05, so let's go ahead and take a 5-minute break. So we'll be back at 7:10. And I'm going to turn off my mic for now. Or the trail map because it goes well with trail mix.
Almost wishing for some trail mix, I have to tell you. Brain power. Ridiculous.
Yep. All right, it's 7:10. I'm going to restart the lecture. And there, some people are checking on the phone. Maybe they're just watching the live stream from outside the classroom, right? Okay, so I'm just want to, oh my, I forgot to click start streaming. Okay, I need it to close. It's active. Shouldn't be active. Close. There we go. Let's close the other one. Oh, this one is still going. Okay. So we have one at least going. Okay. I got 2 instances of the same program going. There we go. Now, to confirm that we are still recording, we can actually just confirm that at YouTube. Right? Yeah. Best way to confirm. So we click on the live now, recording, and then we just have to go all the way to the end. Oh, we got more subscribers. Uh-oh. I just click on the subscribers icon. Okay. Okay, there we go. Yep. So this is like from moments ago, when I got to this page. So you will see that will repeat itself, and then repeat itself, and then repeat itself. And so it looks like it has a lag of about 19 seconds or so, which is about right.
Whoever that was is immortalized now.
Huh? Yep. We just have to beam this out to outer space so that, at some time, some alien can pick it up.
They need to learn how to go too.
If they can travel in outer space, between galaxies, I don't think that's going to be something they need to learn anymore. All right. So we are recording. We got confirmation that we are recording. All right. So getting back to the syntax of the pseudocode. Okay. So we'll go back to the syntax. This is the syntax of the pseudocode. The question is, how close is the syntax of this pseudocode to actual programming languages? Unfortunately, the answer is not very close. Why is that? Okay, so there's a big question, right? I like to ask questions. I like asking questions like why or why not, that sort of thing. And it annoys a lot of people. Okay, so the question is, why is pseudocode like this not used in real programming languages? And what does it look like in a real programming language? Well, in a real programming language, you actually get a few options of how you want to express this. So I can say it looks like this in C, C++, and Java, and JavaScript, and a whole bunch of programming languages based on that family of programming languages. Okay. Oh, I got one extra paren here. We're going to close that. Okay. Z is X, else Z is Y, and that's it. Okay. In C, C++, Java, JavaScript, and a whole bunch of other programming languages that are based on C and C, the original C programming language, it looks like this. But it doesn't mean it's the best way to describe it. Okay. So if you ask most of the other professors will say, oh, try to use curly braces around each block. Okay. So you want to use curly braces around the blocks of code. Now that has to do with the syntax of the entire family of programming languages of C and C++ and Java and JavaScript and Perl, PHP, and so on. Okay, Python is almost the only exception to that rule. So you can always use curly braces. Then the question is, why do I need to add curly braces? The reason is in C and C++, after the then, and after the, there's no then, but after the condition, you can only have one statement. After the else, you can only have one statement. But what if I got two things to do? Well, then you have to put those two into curly braces to make what we call a block statement. In other words, curly braces in C and C++ is a mechanism to combine multiple statements into one. And the syntax of C and C++ is not easy to learn for people who are just starting out to program. And then you may ask, but why is that the case? Okay, does anyone know the history of C and C++? Or C to be more specific, because all of these languages share a common root of C. So does anyone know how the C programming language came into existence? Who was the inventor? For what purpose was it invented? Yes?
Oh, I was just going to say that it was bootstrapped off of A and B programming language.
Yep. And also BCPL, before C programming language.
Ritchie made it, right?
Yes. Very good. Okay, I like that. So I'm going to give you guys a quick history of programming languages, because you're going to have to understand why the next class is significantly more difficult when it comes to syntax compared to this class. So when you look at the C language and you look up Ritchie, I think it's that guy. Okay, so this is Dennis Ritchie, who passed away, I think, within a week. I think he passed away first, and then Steve Jobs passed away. But they passed away within a week. Okay, do you guys remember this guy passing away?
Yeah.
Most people said no, but a few people said yes. So most people go like, well, he's a kind of old guy to begin with, so if he passes away, what is the significance, right? Steve Jobs was young, he was handsome, he was iconic, right? This guy doesn't seem very iconic. We can find like 20 people like this on this campus right now, if you just walk around on campus, right? So what about him? I mean, why is he significant? He is the one who invented with, what's his name? What is the other guy's name? Carnegie, right? So they co-invented Unix. Then you go like, Unix, that sounds like some really archaic operating system that someone is going to use on a mainframe computer 20 years ago. Okay. Who has an iPhone? And who has a Mac OS 10, book and stuff like that? Those are all running Unix. In other words, this guy wrote the original version of the operating system that is currently on your iPhone, iWatch, and your Mac, and inspired Linux as well. So Linux is basically a copycat of Unix, which this guy invented. That was one of his significance. Yes? Go ahead.
So if he didn't create this, then most likely Mac wouldn't be an operating system.
Exactly. So if it's not for him, Steve Jobs would still be kind of writing programs on an Apple II computer or something like that, okay? He wouldn't have a platform to have a successful operating system like we do now. What about Android, okay? Because I seem to be making fun of only of Apple products. What about the Android operating system? What is it running on top of?
Java.
Well, okay, underneath the Java layer, what is it running on? Linux. And Linux is very similar to Unix. In other words, everything that we do now, except for Windows, traces back to this guy. Same thing with programming languages. The C programming language traces all the way back to this guy as well. So now the question is, for what purpose did he invent the C programming language? When he was writing the Unix operating system, he was writing the operating system using what we call assembly programming language. Okay? If you're on the computer science track, you will have to take that class, cisp300, and right now I'm the only person teaching that class, so there's no escape. Yep. But anyway, writing an operating system, which is a pretty significant piece of software using assembly language, is kind of like building a castle out of sand. And we are talking about building a castle out of individual grains of sand. We're not talking about buckets here. We're talking about individual grains of sand using a piece of tweezer and a loop. Okay? And this is a pretty smart guy. And do you think a smart guy like this is going to go like, yeah, I can do this. Eventually I'll get it done. After probably the first few days, he got tired, right? He got totally bored. So he wrote a programming language to make it easier to specify operations. Instead of using assembly language, it's like, okay, now we have shorthands of performing those operations. So those shorthands eventually became the C programming language. Okay? So he wrote the C programming language for himself so that he could write the Unix operating system in a much more effective way.
But who created the assembly?
Assembly existed, well, it has to exist before the C programming language. But when he invented the C programming language for himself, what was his level in terms of programming? You think it's here or way up there? Way up there, yes. So think of this as a contractor, okay? He is building some tools for himself because conventional tools are just too slow and too incapable. Okay? Do you think safety is a concern? No. It's all about power, right? How fast can I rip through that 2x4? Why do you think safety is not the main concern? He's a master of that stuff already. He knows what not to do to cut himself. So the tools that he built was really intended only for the best of the best programmers in his time. And guess what is your next class? C is based on C, which has the same syntax, the same root as C, which was invented by this guy for himself. So that explains why there's a big gap in terms of the syntax that we use in this class, which is pseudocode, which is by design for ease of understanding, as opposed to the syntax of C and C++, which was not designed for ease of understanding. What do you think it's designed for? No.
Efficiency.
Efficiency, very good. Okay, the question was, what do you think the C programming language was designed for? What was the design objective of that programming language? It's not for readability. It's not for education. It is for efficiency. How do I specify the same construct with the least number of keystrokes? That makes it kind of difficult to read. Yes?
I'm just curious, and so what's the modern functionality behind learning assembly?
The assembly programming class is not just to teach the assembly programming language, but it also looks into the architecture of the processor itself, which I see as the most important purpose of that class is to understand how a computer, particularly the processor, is organized. Because without knowing that, we cannot build better processors. But in the process, we also understand assembly language programming because how do you get the processor to operate at the very lowest level? So we also have to explain that. Yep.
We're using assembly code to program a lot of the Internet of Things that we have around our houses and stuff.
Well, it depends on what kind of processor you use. So if you're using an MCU or microcontroller unit, and cost of the device is a major concern, then you might be dropping down to the assembly programming level. Otherwise, most devices can still be C programmed, like using an Arduino or Raspberry Pi is actually not that expensive. But when you embed it into something else, it does get expensive. Question? There was a comment?
They're so fun.
Sorry?
The Raspberry Pis are so fun.
The Raspberry Pi and Arduinos are both a lot of fun. Does everybody know what we are referring to? Were you guys exposed to those concepts? No?
Yes,
Some of you, okay? So we'll go ahead and you will see that I digress a lot in my classes, okay? Sometimes the digression is actually a lot more, I think it's sometimes as valuable as the main topic of this class. So one is called Arduino. Arduino. So the Arduino is a very small circuit board that is C programmable. It is designed to interact with sensors, relays, and stuff like that. Okay, so you can use it to control stuff. The other one is called the Raspberry Pi. Raspberry Pi. You can see I look up a lot of information there because I got projects using the Raspberry Pi as well. So this is the Raspberry Pi. So the Raspberry Pi is what we call a single board computer, about that big, okay? And what operating system do you think it runs? No. Linux. Linux. It runs on Linux. That is cool. That is correct. So that means it brings everything back to this guy again. There's no escape now from this guy. So the Raspberry Pi is based on Linux, which means everything that you can do on a normal desktop computer using Linux, you can do it with a single board computer like that. It has an HDMI port. What is an HDMI port? What do we use an HDMI port for? But what do we hook it up to? External monitors, exactly. So you can hook up this guy to an external monitor, and it has got 4 USB ports. So you can hook up an external keyboard, an external mouse, to this whole thing, and it becomes a computer. It becomes a computer running Linux with a full graphical user interface, which is what I'm using right now. In other words, everything that I can do with that desktop computer, you can do it with a Raspberry Pi. So now the final question, how much is it? Just like the infomercials, right? So I first advertise all the cool things that you can do, and then the next question is, but how much do we pay for this? What about $300? No, let's cut that a little bit. What about $200? So for that, let's go to Amazon and ask. For the first time, we are not asking Google. We are Raspberry Pi 3B Plus. That's the latest edition. And you can see, okay, what about? So if you get this entire kit, it's $80. If you get a single board, where's the single board? $40. And there might be places where you can get it for even less, maybe $35 or so, shipped. Okay? All you need is an external mouse, USB keyboard, and an external monitor, HDMI external monitor. It becomes your computer. It has no hard drive in it, okay? It doesn't have a case, but it's really small as well. So what are some of the applications of something like that? You can bring it anywhere. You can embed it anywhere, okay? Which means if you have a project car and you want to bring a super futuristic dashboard to your '68 Mustang, here's your chance. Put a touch screen on your '68 Mustang that has all the full panel displaying, coolant temperature, oil pressure, right? A big, huge button for nitro. Okay? You can do all of that for what? $35. The touch screen is about $80, okay? And you can interface this thing with, a whole variety of stuff. Does that remind you of the Internet of Things? Okay? This is what enables, this kind of technology is what is enabling the Internet of Things. What about the Arduino? What do you think an Arduino board is going to cost you? So, depends on the generation, the module, and stuff like that. But if we just want to get a sense of, what order of magnitude we are talking about, so where? Yep, $10 for, yeah, it includes the cable even. Yeah, this is the Uno board. The chip itself is about $3 to $4, depending on how many you order at the same time. But this is C programmable, which means after cisp360, you can buy one of these things, write your program in C and C++, and start to do all kinds of control applications. What kind of control applications we are talking about? Well, you can do all the boring stuff like lighting control, temperature control and stuff like that, or you can do something really cool. Okay? Backpack. Put a little motion detector to the back of it and a distance sensor, and then put some really bright LEDs, pointing back to your backpack. So if someone is going to approach you from behind you, like at high speed, you can blink that person. Attach it to a solenoid for automatic pepper spray deployment. And then you have a big warning sign and say, keep off, right? Keep at least 10 feet back. And it can be internet controlled as well. You can leave your backpack in the classroom and then just walk away, use your cell phone, and control that. Arm your backpack remotely. And it can all be done with this sort of thing. Okay? So where do you think on this campus you can learn how to do all that cool stuff? Well, I cannot do that in the classroom. We don't have enough equipment to do it. The Design Hub. How many people have heard of the term Design Hub? Okay, only a few. He works in the Design Hub, so he knows.
I just heard about it today through the Sacramento Developers Collective Discord.
Oh, okay. So the Design Hub is a really cool place. So I know I'm digressing even further and further away. So the Design Hub at ARC has its own website. And let's see here. Okay. I'm trying to look for a website for the Design Hub. Okay. How about we spell out the name? There we go. It's supposed to have its own page somewhere. Oh, I think I know. Okay. So we'll actually look up the URL. designhub.arc.losrios.edu. There we go. Because it does have its own page. So the Design Hub has all kinds of projects. If you look at the projects that we have done, let's see, this is 3D scanned and then printed. So one of the departments on campus, they have these skulls, and the Design Hub scanned the skulls and then 3D printed these things. So this way, if they lose one in the lab or somebody drops and break one, no big deal. We'll just print another one. Great for Halloween as well, as you can see. Let's see here. We also do welding, laser cutting. This is from a game. One of the student group inside the Design Hub spun off to become its own game programming company. So they're actually actively developing a game, hopefully released sometime in around Christmas this year. And then we also do all kinds of other things like drones. So they have a drone program, virtual reality program. There's tons of programming projects with this particular Design Hub. So we are out of room, we are out of internship for this semester. But if you pay attention and apply for internship for spring, you might get in, as a student intern. So how do you like it as a student intern at the Design Hub? And why do you like it? And you're not only learning just programming skills. You're learning a lot of things because you'll be working with artists. You'll be working with 3D modelers. You'll be working with animators, game designers. You'll be working with drone pilots. Okay, we actually have an Arduino controlled module on a drone, and you go like, why would you put an Arduino on a drone? Well, the thing is, we have to fly these drones over a crowd at ARC. So the big question is, what if power got cut off, the battery died or something? We don't want a drone to drop on people, because that's gonna hurt someone, right? So they use an Arduino to sense the loss of power from the propeller. So as soon as it starts to free fall, there's a mechanism to deploy a parachute, so that the drone, without power, would now glide down, gently, instead of just fall down and, and crush somebody's head. Hmm?
I bet that's adorable.
Oh, they tested it. I watched the video of that thing. They flew the drone all the way up to maybe 100 feet or so, and then they cut power to the thing. And then we actually saw, after they zoom in, we saw the deployment of the parachute, because the controller was actually able to sense the G changing, the gravitational pull changing, and deploy the parachute. Except they forgot to fasten the parachute to the drone properly. They were only using Velcro at the time, so there was like maybe 5 seconds, 0.5 seconds or so when the parachute was actually attached to the drone, and then they broke apart, and then the drone just fell 100 feet and broke into tiny little pieces. And then the students just kind of cheered because they had finally got a chance to rebuild the drone. Because most of the parts of that particular drone was 3D printed. So it's okay, breaks apart, 3D print all the parts, put the whole thing back together. So that's basically what we do at the Design Hub. Really kind of cool stuff. All right, so getting back to what we are supposed to talk about tonight. We got about 20